Welcome to product design and development. In this video, we'll talk about generating engineering specification for your product. Looking at the mechanical design process, looking at the four main phases. We said in this course, we don't focus on the last box that's mentioned here, but the four main phases. Phase 2, the keyword we've been using is a spec. And this is the step that we'll talk about. Figuring out who are the customer, what do they need, generating the engineering requirements for them, doing benchmarking, some competition evaluation, and also set design targets. Looking at, again, this is a repeat slide. We are looking at phase 2 of the project, generating engineering specifications. Again, the steps mentioned here in bullet point, as well as a review of what's benchmarking that will be a big part of this step in this phase of the project, which is a study of existing products that either have the similar functionality to the product that we are doing or kind of similar to the product that we are doing. So hopefully at the end of this phase, the biggest things that we can move on to the next phase, which is a step 3, we've used the keyword design or concept for this phase, is a sets of design targets and a clear sets of engineering specifications are the result of this phase. This step is done to understand the design problem. That's basically what we are doing. A lot of problems arises in projects when it's not fully understood what the customer wants, or the sets of specifications are not clear, which both of them goes back to not fully understand the design problem. So this step is often referred to as understanding or defining or identifying the design problem as well. What it means to understand the design problem, it means to translate customers' requirement into technical descriptions of what needs to be designed. So we go from what customer wants to a set of technical descriptions called engineering specifications. In this step, we listen to the customer. There is a document template that we use in this course called Voice of Customer that's used to identify what customer wants. And based on that, we move on to generating engineering specification. Poor product definition or lack of the understanding of the design problem and customer wants is responsible for 80% of the delays in a project from specifically in the time to market of a product. So it's very important. Here's an example of, hey, what customer wants. Customer wants a car door that's easy to open. But as an engineer that you're designing a product, what does easy mean? You see here word easy is a qualitative word, has quality associated with it. As an engineer, you take this and turn it into, again, a technical description, something with quantity and something with unit that could be understood. For example, easy could mean the door needs only, 40 newtons to open. Now, this is something with a unit and a number so that we can measure. It's a technical description. Now it's an engineering term. And this one has quantity attached to it. So we went from quality to quantity. So in this step, we'll focus on the methods to translate customer requirements into engineering specifications. The method that we cover in this lecture is known as quality function deployment, also known as house of quality or QFD diagram. It looks like a house. It has multiple rooms. It has a roof. It has a main floor, and it has a basement. And there are some keywords that we've spread around the house. There's no need to memorize the keywords here, knowing exactly how versus who, how much, all of those. But hopefully by going through this lecture and this video, you can rewrite and recreate this house of quality from memory, again, without memorizing anything. So the goal is that you learn what needs to be going into every step. So if I give you an empty template, you are fully able to fill it out for any product that you are developing. The steps are listed here. We'll go through them one by one. Just some brief, history about QFD. It's been around since 1970s. Started by Toyota, and a decade later started, finding its way into U.S. companies, and about 70% and more of companies in the U.S. kind of use this method and this house of quality in their design problems, new design problems, and redesign problems. And it increases the efficiency. And as you can see, Toyota was able to reduce deployment time by 30%. Again, goes back to understanding what customer wants and having clear engineering specification and description of customer requirements. The example that we use today in this lecture is from a product called aisle chair. I'm sure you've seen this product, this exact product, or similar products when traveling through airports and different airlines. The specific product that we're targeting today and looking at is called aisle chair with the model number. The one we're looking at is these two aisle chairs. So you can look up the product. It's from Columbia Medical Devices, and it's used to transport passengers and individual with disability into their seats on an aircraft. You can see the house of quality, QFD on the right. This is the example where we are going to use. This one is fully filled out. A lot of things going on here. Don't have to worry about it right now. We'll go through it one by one, and hopefully it will make sense at the end of this lecture. I have a simplified version of this QFD like this, so to use it for the purpose of this lecture. So it's the same QFD simplified to kind of only focus on few of each item on each room of this house, so we can go through the lecture. Feel free to capture this screen, pause the video, capture the screen, or I have included the PDF version of this for this lecture. You can print it on a large paper and kind of follow along with this video, or I have a little bit larger version here. Again, feel free to pause the video, screenshot it if you can have it open on a different screen, so you can better follow throughout this lecture. So let's get us started with step 1 through 8 and understanding what each of the rooms of this QFD means and how to use it and utilize it. Starting with step 1, and the keyword for this was who. And this is figuring out who the customers are, and who are you designing this for, or whose customer requirements are you translating into engineering specification. In order to do that, a silly way or a kind of easy way to do that is to pretend that you are the product. So close your eyes, visualize that you are the product. So now you visualize all the people that you will encounter as you go through this project and this design process, from beginning through retirement of this product. All the people that encounter you as you go from the beginning of the project all the way to retirement are called customers. For any product, usually there is 5 or more classes of customers that you got to consider their voice and their requirements in product development. For this lecture and for this example, for the product we're looking at for aisle chair, the main customers that we consider for this example are only the passenger being transported and the agent who helps the customer or pushes the customer or the passenger around. So that's the who section of this this video. Sorry. One thing to consider is for this example we're looking at the passenger and the agent, but when you think about it, none of those two have purchased this aisle chair. None of them own it. None of them pay for it. None of them clean it or repair it or disassemble it or assemble it. So it goes back to the first point that I made, that pretend that you're the product and whoever comes in contact with you is the customer. Again, it's not always the person who buys the product is the customer. Again, somebody who uses it is the customer. In this case, the airline bought it and paid it. Someone else probably assembled it. Someone else probably repairs it. And then the passenger uses it. The agent pushes the passenger around. So it's important to consider. So it's important to, again, figure out who are the customer and who are you focusing on to develop the specifications for. So we're done in step one. Looking at step two, and it's what the customer want. This is when the customer requirements and voice of customer comes into play. Some examples I've listed here. For example, the consumer, whoever uses the product, end user of the product, usually wants the product that works as it should work. It lasts long, easy to maintain, it looks great, it has the latest technology, has so many features they can use, and so on. Production customer within the company or outside of the company, whoever is going to make that product that you are designing, wants something that's easy to produce. They don't have to go and search for skills or equipment or raw material. They can use whatever they have available to them to produce that. Has a lots of standard parts and production methods, so not too many customization on it. Again, goes back to the same point. They can use their current existing facilities to do that, and it's an efficient way of producing. So not too many scraps, not too many reject parts, tolerances are not too tight, and so on. On the other hand, when people are working on marketing and sales, they don't care much about any of those. They care about, hey, how easy it is to package it, assemble it, or disassemble it, or ship it, or transport it. Also, how good looking it is, so we can use it to sell this product as a selling point, and so on. Another point to consider, when it comes to customer requirement and what customer want, you can collect those information. Again, depending on the scale of the project, you can collect that information by different methods. You can, if it's an existing product, you can observe and see what customer want, what are they using it for, and so on. A questionnaire, again, voice of customer is one of the templates that I've made available for this class. You can use the questionnaire to, sets of questions. You can modify those sets of questions to gather what customer exactly wants in this product. There are different ways of surveying people. Again, for existing product or for a new product. Focus groups is another way of doing that. All depends on timeline of project, scale of the project, how much budget you have available for this phase of the project, and so on. Another good point to mention here before moving on is this diagram on the right side, the Kano model of customer satisfaction. One side, it has, this talks about features in a product. One side of the axis, horizontal axis, the feature is absent. We'll talk about what that means. And then the feature is fully implemented. Another one, the vertical axis is a disgusted and delighted kind of scale. So now I want you to pay attention on this side. Three main features we define for a product. Basic feature is something you expect out of a product. If you buy a car, you expect it to drive. You expect it to have brakes. You expect it to have comfortable seats. You expect it to have a good steering wheel. So those are basic features that comes with a car. So those are usually the functions that are not verbalized. So if, now let's look at the basic line. If those features are absent, the customer satisfaction is kind of at disgusted level. They're like end of basic feature here. If those features are implemented, great. They're not going to result in any excitement in customer. They just customer kind of at a neutral point at that point because they expect the features to be existing. One level higher than that, performance feature, is something that if it's better, it makes the product perform better compared to competition. A good example of it is when you buy a vehicle again, you might have, pretty much all vehicles these days have ABS brakes, for example, anti-lock brakes and anti-lock brake system. Again, if that is available, it makes the product a little bit better compared to others. So absence of it, again, customers kind of expect that to be there. And if it's not there, customer is not satisfied. But then as you progress, and then if it's fully implemented, you're kind of end of this arrow here, then the customer is very delighted. So that has a linear relation. And then last class of features is excitement feature. It's something that the customer doesn't expect in a car. In a product. A good example of a car would be, I don't know, you buy a car and the customer realizes, oh, it has wireless charging station for your cell phone. That's something the customer maybe particularly wasn't expected, but it kind of makes them excited about this product. Again, absence of it because the customer doesn't expect it, they don't know about it. They're at a kind of a neutral stand. But as those are more implemented, the customer moves towards delighted status on that excitement graph. One thing to also consider is over time, and that's what this time portion of this graph is. Over time, the excitement feature becomes performance feature. Performance features become basic features in a car. If you buy a car that has a wireless charging station for your cell phone, the next car you want to buy, you kind of automatically expect that to be there. So that becomes a performance feature or even a basic feature. And that's what it means over time. Looking at step 3 and who versus what is figuring out the requirements that you found in a step 2. Which group of customer cares about which one, and how much they care about it. How much? So that's done through generating a weight factor for each of those requirements. That tells you how much effort, time, money to invest to achieving that requirement. It doesn't mean you should ignore it if the weight is low, but some of the higher weights, that means you put more effort, time, and money invest in it. And then so it's kind of a relative measure of importance of that customer requirement to each group of customer. This will help us in the next step 2 when we go to step 4 and 5 to figure out which customer requirements we need to focus on a little bit more. So typically, in a lot of weight systems, a scale of 1 to 5 or 1 to 10 is used. The problem with that is then everything turns out to be 8, 9, 10 because everybody thinks every customer requirement is important. A better method that we use here is fixed sum method. What that means is, kind of solve this problem. We give you 100 points, and you have only 100 points to spend on all of these customer requirements. So hopefully if you sum up each of these columns here, the sum should be equal to 100 points. So that means if you are down here and kind of spend all your 100 points already, you got to go back, revise, maybe reduce some importance on some factors, and then have some points to spend down here too. This is to make sure that these are relative to each other and not relative to a absolute fixed number. So it's important to understand how these relate with each other. So the example, if you're following along, you can look at these are percentage of, again, or weights of how important it is some aspect to the customer. For example, for the passenger and for the agent, one of the ones that have kind of high weight is the aisle chair movement and good stability. For the customer, for the passenger, agent maybe cares a little bit more about the efficiency of transport, and then good lifting position, as you can see, and so on. So you can go through it and kind of with a little bit more time and kind of understand what each means. Please watch the rest of the steps in part 2 of this video.